Bună ziua, în primul rând scuze pentru întârziere, am avut probleme tehnice legate de conexiune, fiind într-o locație diferită de cea în care se desfășoară de obicei aceste evenimente, aceste conferințe ale Institutului SARU-BB. Așa cum ne-am obișnuit, Institutul SARU-BB invită periodic personalități din diferite domenii, în scopul de a crește internaționalizarea resursei a comunității academice a universității și în acest context, astăzi avem deosebită onoare să-l avem în mijlocul nostru al comunității Universității Babeș-Bolyai pe domnul profesor Cluj-Napoca, care este profesor la Institutul de Chimie Farmaceutică al Universității SZEGED din Ungaria și care, ne mândrim, este absolvent al specializării chimie a Facultății de Chimie din anul 1996, cu masteratul finalizat în 1997. După finalizarea studiilor universitare de bază, domnul Cluj-Napoca a efectuat un stagiu doctoral la Universitatea din SZEGED și după aceea, așa cum ne va povesti în continuare dânsul, a avut diferite etape de pregătire. În seara aceasta ne va prezenta o conferință în domeniul chimiei organice, referindu-se la funcționalizarea selectivă a unor aminoacizi neselectivi. Îl invit pe domnul profesor Cluj-Napoca să ne prezinte de la
Mulțumesc frumos, mulțumesc pentru prezentare, stimați colegi. Chiar de scurt, am deosebită onoare de pot să prezint cercetarea de la SZEGED, cercetarea efectuată la Facultatea de Farmacie Universitatea din SZEGED.
You can speak in English. Okay?
Deci, aș dori să vă prezint pe scurt. Am terminat la Facultatea de Chimie, secția Chimie în 96. În 97 am terminat masteratul Chimia heterociclică. După aceea, în 2002, am obținut doctoratul PhD la Facultatea de Științe din Debrecen, la Departamentul de Chimie Organică. În 2003 m-am mutat la SZEGED, la Universitatea din SZEGED, Facultatea de Farmacie, unde am obținut o poziție de profesor asistent. În 2003-2008 am devenit director, după aceea conferențiar până în 2017. Am obținut abilitatea la aceeași facultate. Am lucrat în domeniul aminoacizilor. Am obținut doctoratul la Academia de Științe Ungare în 2016 și în 2017 am fost desemnat profesor universitar și în același an director de departament la Institutul de Farmacie Clinică. Am vizitat câteva universități din Europa, din Statele Unite, din Japonia. Cred că cea mai lungă perioadă, postdoctoratul la Universitatea din Ghent, din Belgia. În 2005-2006 am lucrat cu profesor Norbert de Quinte. După aceea am petrecut câteva perioade la Universitatea din Valencia, lucrând cu profesorul Santos Fusteru. Pe scurt, aș dori să vă prezint câteva date scientometrice. Am 117 publicații în reviste internaționale. Impact factorul total este de 407. Hirsch indexul 27, pe Google Scholar 31, este un indice foarte important în privința evaluării lucrării științifice. În 85 de publicații sunt primul autor sau autor corespondent. 6 studenți de doctorat au terminat cu care am fost consultant științific. Conduc școala doctorală de la Universitatea din SZEGED. în domeniul chimiei farmaceutice și țin curse pentru studenți doctoranți. O activitate foarte importantă este activitatea de lector la diferite reviste de prestigiu, Elsevier, Royal Society of Chemistry, Babeş-Bolyai, American Chemical Society. Aici am listat câteva reviste de prestigiu. Sunt editor, associate editor la SYNTHESES și European Journal of Organic Chemistry. Pe slide-ul 5 am listat câteva prezentări de conferință, poate cele mai importante din Barcelona, din Regensburg, Germania, din Ghent, Belgia, din United States, din Statele Unite ale Americii și Florida. Pe partea dreaptă am listat câteva publicații importante, poate cele mai importante, cele mai citate publicații: European Journal of Organic Chemistry, Chemical Reviews, Chemical Records, Amino Acids and Organic Letters. Avem colaborări cu diferite grupuri internaționale, am listat aici pe slide-ul 6 câteva dintre colaborările curente. Aș dori să menționez profesor Santos Fuset din Spania, profesorul Takahiko Akiyama din Japonia, Norio Shibata din Japonia, Vadim Solosonok din Spania și probabil David O'Hegel din Marea Britanie este cel mai important, sunt cei mai importanți. Despre viitor. Peste 2 săptămâni mă mut la Budapesta, am obținut un post de director la Institutul de Chimie Organică, la Centrul de Cercetări ale Științelor Naturii din Budapesta. Aici vedeți o pictură despre Centrul de Cercetare din Budapesta. Now I'm going to turn to English to present my scientific activity, the scientific research performed at the University of SZEGED Institute of Pharmaceutical Chemistry. So, being a university and the Institute of Pharmaceutical Chemistry, our research should be directed and is directed toward the drug research involving organic chemistry, pharmaceutical chemistry. Our work was focused and is continuously focused toward the development of modern techniques, novel synthetic methodologies, bioactive compound libraries creation, and two main basic area of research are synthesis and application of highly functional small molecular entities, derivatives of amino acids and acetylcycle cycles. The second, the next important topic is about organofluorine chemistry, fluorinated amino acids, functionalized alicycles, and heterocycles. Our aim was to develop new synthetic methodologies to create novel functionalized molecular entities. Therefore, it was an important task to develop selective stereo, regio, and anti-chemio selective chemical transformations, to investigate the substrate selectivity, substrate controlled chemical methodologies, to develop diversity-oriented synthetic methodologies, and to carry out divergent synthetic strategies. By using these approaches, we created molecular libraries including three-dimensional small molecular entities such as amino acids, nitrogen-containing heterocycles, saturated carbocycles or heterocycles, molecular entities with chemical and structural diversity, and molecules with multiple stereogenic centers, which might be important scaffolds in pharmaceutical research. When I enjoyed the Institute of Pharmaceutical Chemistry, I started to work in the field of non-natural amino acids. Beta amino acids are far less abundant than alpha amino acids. They are known as bioactive compounds, some of them, antibiotics. They are elements of natural products, precursors of beta-lactams, or building blocks in peptide synthesis. Some beta amino acids are used as chiral building blocks for asymmetric synthesis. Here in this slide I listed some important beta amino acids. CISPENTACIN, which is an antibiotic, fluoxetine, also an antibiotic, oryzopsimycin, possessing antifungal activity, ticofungipen, antifungal agent, and tilidin, which is known as an analgesic. Several cyclic amino acids with multiple chiral centers, highly functionalized scaffolds are known important drugs. Oseltamivir, zanamivir, peramivir, or inavir are some representatives from this area of derivatives. Beta amino acids are not only small molecular entities known possessing bioactive properties, they may be elements of structures, bioactive compounds with complex structural architecture, such as hemipuromycin, blasticidin, criscandin, or here I included the structure of imudivir, which is an antiviral agent. Some heterocyclic amino acids containing nitrogen or oxygen in the ring are also known as antiviral agents. Anatoxin analog is an alkaloid, or proline analogs are also known as catalysts in asymmetric synthesis. However, fluorine-containing organic compounds are absent, literally absent from nature. It is important to note that 25 to 30% of the newly introduced drugs contain fluorine atoms. Due to the important characteristic of fluorine atom, or the carbon-fluorine bond, by changing the functional group or hydrogen atom in the structure of biomolecule or an organic molecule, may have profound changes on the physical chemical properties, on the acid-basic character, or reactivity, but most important, it will have a high effect on biological properties. Here on this slide 12, I listed several fluorine-containing common drugs. Probably the most interesting for us are the beta-lactam-containing ezetimibe, yofluban, which is also contains beta amino acid scaffold, or sitagliptin, an antidiabetic, also possessing a beta amino acid scaffold. On the next slide, I included several blockbuster drugs, which whose income was about $1 million during last years. Taking into consideration the high importance of cyclic amino acids, derivatives of cyclic amino acids in pharmaceutical research, such as Tamiflu, oseltamivir, zanamivir, inamivir, or peramivir, also the importance of fluorinated organic compounds, our aim was to develop synthetic methods to approach this class of compounds. Here I listed a general scheme, including the starting materials, which are unsaturated cyclic amino acids, some of them containing bicyclic system, and by transformation of the carbon-carbon double bond under stereo control and selective approaches, we synthesize a large number of functional derivatives. Our main focus was the development of novel methodology toward the access of this class of compounds, functionalized amino acids, fluorine-containing building elements, possessing high chemical and structural diversity, involving stereo-controlled and selective transformations. Most important methods and techniques were based on the selective transformation of the carbon-carbon double bond by oxidation with a their acids under stereo control and following by oxidant opening reactions. The next approach was the involvement of dialkyl cycle addition to the carbon-carbon double bond. Next, regio and stereoselective iodolactonization, regio and stereoselective iodo-oxazine formations, followed by oxazine opening reactions, were several approaches. Furthermore, acidylation and selective opening of the azidyl was the next approach for the functionalization. And the carbon-carbon double bond ring cleavage under positive conditions allowed us to synthesize novel molecular entities. Selective fluorinations were was the next goal, which involved carbon oxygen bond formation, in general hydroxylation, and followed by a hydroxyl fluorine exchange in the presence of nucleophilic fluorinating agent. Another research field was the palladium catalyzed transformation, functionalization of the carbon-carbon double bond of the unsaturated amino acids, and ruthenium catalyzed metathesis approaches. Here on slide 15, I included one reaction, one transformation, which was highly cited paper, Organic Letters, in 2015. Beta-amino acid derivative, beta-amino acid, protected beta-amino acid 29, was subjected to bromonium-induced functionalization by forming an azidine ring, which had a cis-relative relationship with the carboxylate and the carbamate functional group. Next, we submitted to nucleophilic ring opening by fluoride, and for this purpose we used some novel fluorinating reagents, commercial available fluorinating reagents listed in this slide. In general, X-fluor and deoxyfluor were the best reagents for carrying out this reaction. The reaction could be carried out in the presence of X-fluor in dioxin as solvent at heating during 10 minutes. Direct fluorination involving hydroxyfluorine or oxofluorine exchange, it's called the late stage fluorination, but it might be that some chemical approaches require building blocks, fluorine-containing building blocks, such as fluorinated amines, to carry out incorporation of the fluorine-containing entities. The next approach for the incorporation of fluorine into the skeleton of beta-amino acid was based on the selective epoxidation of the carbon-carbon double bond. Proceeded again with cis-stereo control distereoselectively. The oxygen ring, due to the hydrogen bonding interaction, was formed the same side as the carbamate, so they have a relative cis configuration. Under various experimental conditions, we were able to incorporate fluorine atom into the skeleton of the beta-amino acid. The method could be extended not only for the synthesis of functionalized beta-amino acids, but also for the incorporation of fluorine in novel molecular entities possessing different functional groups, so the method could be generalized. I would like to mention that on the side of Sigma Aldrich, searching the oxofluor solution, it was included as reference for article published in the European Journal of Organic Chemistry in 2011. However, this site doesn't exist anymore. X-fluor also was incorporated in this chemical company site, Aldrich, and our article Organic Letters, published in 2015, was given as reference. Currently, Merck includes this article in the references list when showing us X-fluor reagent. Another approach, as I said, is based on the incorporation of the fluorine atom based on the application of the fluorine-containing building elements. Our approach started from cyclic amino acids, cyclic amino acids, which I have to mention they were synthesized in multiple grams, hundreds of grams, could be synthesized in racemic forms and also in enzymatic form by enzymatic resolution of the static beta-lactam derivatives. The reaction was based on the oxidative ring cleavage under ozonolysis or periodate oxidation, providing valuable dialdehydes, which next were submitted to various fluorination methodologies such as difluorinations, but also under reductive amination conditions, heterocyclic amino acids could be synthesized. Here in slide 20, I listed two examples, starting from diexo beta-amino norbornene diexo beta-amino acid 37 by dihydroxylation of oxidative ring cleavage provided the corresponding so-called transaldehyde in which the formyl groups and the ester and the carbamate they have a relative trans configuration. Next, by using fluorinated amine, double reductive cyclization under reductive amination provided the corresponding bicyclic azepine beta-amino acid derivative 39. It should be mentioned that the reaction proceeded with stereo control. The structure of the starting material determined the structure of the product, so proceeded with the conservation of the chiral center, configuration of the chiral centers. Next, another isomer, diendoisomer, under similar condition provided a new isomer, 42, and again the reaction proceeded with stereo control. I should mention that we could eliminate the dihydroxylation step in general using ozone tetroxide or periodate by ozonolysis. Simply the double bond could be immediately cleaved to the corresponding dialdehyde. Here on the slide 21, I listed several products synthesized based on this approach, oxidative ring opening, reductive ring closing, and probably the most important result is the transformation of the indene, providing dihydroisoquinoline derivatives, and this is a new method for the creation of this ring system. And as probably you know, besides Babeş-Bolyai typically single reaction might be considered a useful approach for the creation of this heterocyclic system. Next, our aim was to carry out other functionalizations by using transition metal catalyzed approaches. Starting materials were the corresponding unsaturated bicyclic beta-lactams or beta-amino acids, and we carried out the functionalization either by modified Heck reaction or metathesis transformations. Here on this slide 33, I listed a reaction which involved modified Heck reaction, amino ester 43 in reaction with aryl iodide in the presence of palladium acetate provided the corresponding ARYL-SUBSTITUTED derivative. This is an important functionalized effort which might be interesting building element in peptide synthesis due to the pi electron system, important skeleton which might have an effect on the secondary structure of peptides. The reaction mechanism is included here, so proceeded with stereo control and substrate control. The aryl group was connected to carbon number 4, and intramolecular attack of the carbonate oxygen atom provided the corresponding intermediate T4, which after elimination by a double bond migration provided the target molecule 44. The reaction could be extended toward the access of various ARYL-SUBSTITUTED amino acid derivatives also. Next, we submitted the starting materials already presented, norbornene beta-amino esters 45 and 47 into ring opening in the presence of deuterium-based metathesis catalyst. Ring opening in the presence of Oveda Grubbs and Grubbs catalyst provided corresponding diagonal substituted derivatives. It is important to note that when isomerization of 45 is carried out in the presence of base, the corresponding so-called endo-exo derivative provided another isomer with stereo control. Next, these divinyl groups offered us the possibility to include novel functional entities in the skeleton of the beta-amino acid. Therefore, we selected unsaturated ester, which in reaction with the amino esters, diamine amino ester 51 and 48, provided the corresponding dimethyl product. This is not a curious result. However, we realized that selecting by selection of the reaction conditions, careful selection of the reaction conditions, by changing the amount of catalyst, the temperature, and the reaction time, discrimination of the double bonds connected to the cyclic pentanene ring could be performed. And we observed that the vinyl group connected to carbon number 3 reacted, and the other vinyl group was remained untouched. This selectivity can be explained based on two aspects to phenomena. One is based on the hydrogen bonding interactions, and the second includes the intermediate, which is a metal cyclobutane intermediate, in which oxygen coordinates to the deuterium atom, and therefore provides a highly stable, so-called cis-annihilated system, which results in the monometallized product. Next, we investigated the metathesis reaction of divinylated product 46. Important to note, the ester and the vinyl group from position 5, they have trans-relative stereochemistry. Cross-metathesis reaction provided, in this case, two products. The reaction was not selective, provided two products in 4:1 ratio. The products could be separated. How we can explain this result? In the case of divinylated compound 46, instead of a cis-annihilated intermediate, a transfused annihilated intermediate resulted, which is not stable. Therefore, provides in as mine product compound 57 or 58. The methods could be extended and further applied toward the access of various functionalized scaffolds. For starting materials, and our aim was to use cheap starting materials or starting materials for cyclodienes, cheap starting dyes from commercial sources, and either by beta-lactam formation or dipolar cycle addition, selectively a single double bond could be functionalized, and the next double bond, because of the ring strain, in several cases could be transformed under metathesis condition. Within the pharmaceutical chemistry research group, Faculty of Pharmacy, our intention was to carry out biological investigations of these scaffolds, prepared scaffolds, and we performed these assays by involvement of collaborators from Belgium and from Mississippi, United States, or Colorado, United States, and several antifungal, antiviral assays were carried out. What is our purpose for test? I should say that mainly publications of the novel results. This is the important aspect of research. But also is also important the application of all results, applied research, and application of all compounds or methods in pharmaceutical industry. In drug research or health, we have several collaboration with pharmaceutical industry, pharmaceutical companies in this view. Also is very important aspect that we always studied the chemical and biological behavior of small molecular entities. In general, we carried out those experiments which are not exactly predictable from start. So therefore, we were always curious to see the outcome of this reaction, the outcome of this experience of these chemical transformations. And this, I should say, that there were driving forces during our continuous research. About the future trends, I would like to mention 4 publications published in chemical reviews, 2 of them based on the results obtained in the area of amino acids and on organofluorine chemistry, another in journal fluorine chemistry, and another in amino acids. So those articles are called Next Generation Organofluorine-Containing Blockbuster Drugs, published last year. Chemical Aspects of Human and Environmental Overload with Fluorine, published in Chemical Reviews in this year. Synthesis of carbocyclic and heterocyclic beta-amino acids, published also in Chemical Reviews several years ago. And another work including peptide research, published in Amino Acids in 2017. And taking in consideration the importance of organofluorine compounds and of non-natural amino acids, we believe that these publications and all results may open new trends in the future drug research. Here I listed several aspects of our intentions, which are related to computational studies, to application of orthogonal protein conformation of dicarboxylic amino acids as building elements in peptides, synthesis and application of aromatic and pi-electron-rich system in peptide chemistry, functionalized small molecular entities used in the studies of protein-protein interactions, functionalized beta-protein analogs used in asymmetric synthesis or application of organic catalysis, functional conformationally substituted gamma amino acid derivatives, also conformation rigid gamma amino acid derivatives. And finally, taking in consideration the importance of those bioactive compounds which possess complex structure, where they include beta amino acid element. Another future trend might be the fragment-based drug design. I should say Pimodivir and Triscandi are 2 important bioactive compounds in this view. And finally, I would like to thank you for your attention. And this is my small group with PhD students, thesis students, and unfortunately, I'm going to leave them within a couple of days. Thank you for your attention. Mulțumesc pentru atenție.